Yeah, this one's set up for like 1800 horsepower.
This is the stuff everybody drools over and sticks their fingers into.
They start out as a block of aluminum, and then this is the first operation. Little top secret here. This was the very first machine. And want to leave a little bit of a sharp angle on the bottom cut. That helps reduce reversion.
He's on lots of drugs. So we were gonna do like this real nice, like, oh hey, welcome to this late model engine stuff, but you know, doing work. That's just how it is in real life here.
No doubt, man.
Nothing staged. This is our intro.
Hell yeah.
So we're out in Houston at Late Model Engines with the man who owns it and founded it, Bryan.
What's up, man? Bryan Neelen, Late Model Engines. We're here in Houston. Gonna show you guys around our shop and show you a little bit about our process and how we make some horsepower.
Yeah, so I guess we'll start where it would start if you brought your motor here like I just did.
Yeah, pretty much. Yeah, we pulled it in right here. We'll unload the truck. It will ultimately go back into our teardown area, and from there it makes the whole loop through the shop, through our process.
We'll head back to this teardown area and see some of the torn downness of my own motor, which you can check out in a different video if you haven't seen that already. But
yep, so here you are right here. So basically we'll put it up on an engine stand. We'll get the engine torn down. If it's a brand new engine, you know, brand new engine block, which is common, we'll take the engine block out of the crate and we will start with the line hone. So this engine here, not being a brand new block, it's disassembled. We're gonna clean and inspect it to make sure that it's a worthy piece. We have, our initial thoughts are that it's a worthy piece, so we're gonna do some more, we're gonna do a little more checking before we get too crazy on it, but it'll go through our jet wash and ultrasonic cleaner to do our preliminary cleaning to get it ready for machine work. The first step of the whole process is the line hone. So this is what's going to establish the center line of the main. So the block will go in this machine upside down, and we will hone all of the main housing bores at one time with this mandrel. So a brand new block, we will cut the caps as well as a used block. So I talked to you about earlier in the other video, cutting the caps. This is here, your cap grinder. So the main cap will go into this grinder. It'll clamp down, and we'll able to actually grind the surface of the cap to make the housing bore smaller.
that's cool. I've never seen one of these before. That's some stuff, like some serious industry. What's the vintage on this stuff? I know the best stuff is always like,
yeah, so this one is actually probably from the, if I were to guess, probably from the late 70s or 80s. If I were to guess, the red, all the sunning gurus might know what this one is, but yeah, it works well. They used to have an old stone, but this is kind of the new technology, is using a CBN material. So a lot harder. You don't have to dress it. It stays super flat and creates a really nice surface finish. So once we've cut those main caps, we'll get it in here. We're able to get our housing bores round and straight 4 decimal places out. So the distance between 0 and 1, each one of those is a tenth, which is 0.0001 of an inch. And we're looking to have the housing bores absolutely as round and straight as possible. So when we're in the assembly room and we're checking our bearing clearances, we have consistency from one to the other, as well as having the journals in line with each other. So there's no distortion that way. So that's crucial. This is kind of the foundation of the entire process, is the line hone. You know, when you talk about blueprinting a block, it's not only doing all of the different operations, but it's the order of operations, which is extremely important. So everything starts with the line hone. If you think of a blueprint and an engine, you have the center line of the main out to the deck surface, the center line of the main out to the other deck surface, that angle, which we're going to correct in the next machine, getting those surfaces perpendicular to the mains. You've heard the term 90-degree V8.
yeah,
That's where that comes from. So we're actually making the deck surfaces perpendicular to the mains. So it all starts out with the main. If you surfaced your block before you line honed it, you would actually change the center line of the crankshaft by a couple thousandths potentially by machining it after the fact, because you're actually dropping the housing bore closer to the cam essentially when it's honed.
interesting.
So that's the first process.
You know, all kinds of cool stuff in here. I was just looking around at all this billet awesomeness. We'll check that out in a little bit.
So the next process is going to be going into our 4-axis CNC, 50 taper CNC machine, very rigid, very powerful machine. This is an LSX block that we have in here now. This one has not been machined yet, so this is getting ready to be machined. Once we have it up in this machine, we've indicated it in, it will rotate on the center of the mains. So the center of rotation of this rotary table is the center line of the main, and then we have the block indicated off the main and the cam. So we probe the thrust surface on the main and the dowel pin here. That gives us our X and Y axis for the center of the bores. The deck surface goes off of the center line of the main and cam. So all this stuff is pre-programmed. We're not sitting and programming for each individual block. It's essentially we're running a precise program for the LSX block to give us the bore size, bores that are perpendicular to the mains, as well as the deck surfaces that are perpendicular and to the right height. In this machine, we'll also do the 1/2-inch studs to your stuff, as well as the receiver grooves. So each program will bring that up, and we have the tooling all made up to achieve those different dimensions that we're trying to machine here. So any questions?
So when this is in here, if it's doing multiple tasks, do you just set it and let it run? Like, could it, do something and then change its own tool and cut the receiver groove?
Right.
Or do you like check it after everything it does?
We can do both. So we have it dialed in. For example, on this LSX block, if we have a specific program that will run the clearancing for the stroke, the deck surface, 1/2-inch stud, and boring it, let's say for a 4125 finished bore. All of that will be one program. Then we'll run a separate program for the receiver groove. So that'll be a 2-program run.
Interesting.
So all of those first operations we'll just run through there basically with the push of a button.
When you said that you started this place with your partner in 2003.
Yep.
When did you get your first CNC machine? When did you stop doing everything yourself by hand?
That's a good question. Matter of fact.
And which one was it?
I'll show you.
What's your baby here? I know you got one.
So this one right here. This is it. This was the very first machine, and we actually had this given to us by a good friend of ours, and he told us to take it away for scrap metal. And it was an old punch tape computer. You ever see the computers that run off of punch tape?
Yeah.
Yeah. So that was this thing right here. Old school CNC machine, and it's actually a Bridgeport brand, so it's actually a very high quality mechanically, really nice machine. And then we outfitted it with this retrofit electronics here. So we've got a computer, a normal computer in the back of that cabinet. It's got the DC motors, and we can run, like, we'll gas port pistons on this. We run different little CNC programs on brackets and front covers and stuff. We clearance for double roller. If any of you guys ever been building an LS with a double roller timing set, you have to clearance for the front cover for the oil pump that gets spaced out. We got a nice little CNC program that we bolt the front cover right in here. It machines for that, and it just makes life super easy. This is set up for gas ports here. So yeah, this thing works like a champ, and that was our very first CNC machine. That's
insane. I didn't know you could retrofit these old things with CNC stuff. That's like the coolest thing ever.
What is pretty cool, so as you see this control here.
Yeah.
You look at this machine over here, you got a $250,000 5-axis CNC machine with the same control, right? It's the same company that makes both.
It's the same panel. I mean, I guess that makes sense. The mechanisms, they do the same thing. If you just put motors on it instead of where your hands go.
Pretty much.
That's freaking awesome. What's that thing from, like the 40s or something?
I think it's from the 60s probably, I'm not sure.
And it's still kicking ass. That's awesome.
Yes, sir. A couple 5-axis CNCs. This is kind of getting away from the blueprinting process. So we would go down the line, but I'll show you the CNC equipment here real quick. So this is one of our 5-axis that we do our CNC ported heads. This just got done running some LSA heads, and we're actually fixturing up to do another process here. So there is no cylinder head in there right now. But it will be running here just in a bit. This is another machine we have. that is a same basic machine, just different manufacturer. 5-axis CNC. It's running. It was doing the ID of the ports for our billet intake manifold. This is where we are making billet valve covers. These are LT billet valve covers. It's running an O-ring groove right now in the for the valve cover gasket. Hard to see in there, but it has a little O-ring groove tool that it is machining. And then this guy here, this is making the just did a tool change. It's gonna be tapping the hole right now. So it just went in reverse directions at the bottom, just like a normal tap.
Oh yeah, you can see it changes direction so fast you can barely tell.
Yeah, and it's actually thread rolling. It's not cutting thread forming. It's not cutting the threads. It's actually forming the threads in the hole.
It's a little stronger.
It's a little bit stronger, a little denser. So it has 2 snouts in there right now. It just did the 2. It's going to change another tool. Probably going to run. Yeah, it's going to be doing the O-ring groove for the throttle body O-ring.
So did you have the whole reliable over there retrofitted with CNC stuff before you had your first cabinet?
Oh yeah.
You did?
For sure. We kind of had a progression of, we went from that machine just to get our feet wet with CNC. That's really what started LME, or the thought of having late model engines was because of the CNC technology. So both myself and my partner were working for other machine shops building race engines, and they were kind of more old school in terms of the equipment, more manual machines, all that. We're super young and knew we wanted to do this for a long time, so it made sense that if we were going to be successful, we needed to learn CNC machining. So with our little side gig we had going on, we got that, kind of by default ended up with that CNC machine. So we got it working the best we could, as cheap as we could. And then we progressed into an open bed, larger machine that we could do blocks on. So that was our second CNC machine that we don't have anymore. We got rid of it and we replaced it with the one that we had the LSX block in. So that was a huge step up. I mean, the cabinets there's a lot more capabilities. These are all these ones in the back here are really new machines. They're latest and greatest technology, and they're pretty killer. So yeah, it's actually machining the logo is what it's doing right now.
Coolest part.
Yep. So all of these snouts, they start out as a block of aluminum, and then this is the first operation, and then the second op we're going to flip it over, and then it will come out as the finished part. I don't know if we have. Yeah, we don't. The first 2 on this run are in the machine now, so we'll check those out later. A little behind the scenes here is our C8 manifold. So that's a little top secret here. So we should have that first one ready here in the next, hopefully, several weeks. We have one more project that we got to finish out, and then this is going to be our C8. So it's going to have a huge lid. There's a ton of room from the bonnet, hood, whatever you want to call it, to the C8. So we have a lot of room to play in there.
That's freaking sweet looking.
It's gonna be nasty, man. It's gonna be really nasty.
So where do if we jump back to the assembly process?
Yep.
What happens after we go here?
Once we come out of this machine, we're gonna go over to the cylinder hone. So going to the cylinder hone, this block just got finished up, but you can see here, very consistent crosshatch. We put a lot of focus on the surface finish, as we were talking about earlier. I mean, that's you got your geometry of the cylinder bore, how round and straight it is, and then you have the surface finish that you're actually achieving. So with this basically a CNC hone. It can auto dwell, so it can sense taper in the cylinder and dwell in those areas to help get it as straight as possible. And then kind of by default, this honing head, it has a diamond abrasive, which creates just a very consistent and round cylinder. Again, we can get it round and straight out to 4 decimal places. We've got our different torque plates for different applications. This simulates the cylinder head being torqued onto the block. When you torque the torque plate or a cylinder head onto the engine block, it actually distorts. It'll distort the cylinder in a certain way. That's and then we want to hone it straight and round in that distorted state. So when we bolt the cylinder head on, it goes back to a round. So when we take the torque plate off, it goes out of round. Then when we bolt the cylinder head back on, it distorts back to a round condition, round and straight. Talking very, very minimal and you know, fractions of an inch, but all that matters. The profilometer that we were talking about earlier is just this guy right here. So this little ruby head at the end of this deal here, we put that onto the clean cylinder wall, and that allows us to get different parameters of the crosshatch. You've got RA, RPK, RVK. Basically what it boils down to is, if you look at a crosshatch under a magnifying glass, it might look something like this, right? So you have your peaks and your valleys.
Mm-hmm.
We can measure how deep the valley is. We can measure the distance at the bottom of the valley, and then we can measure the distance between the peaks. For example, so you have those, and then the average of all of that. So you have all of that that goes in. It's all about oil retention. So if you have too much oil retention, your engine can oil excessively. If you don't have enough oil retention, the rings have nothing to seal on. So it's a balance, and we create a specific recipe of abrasives that we use to achieve the surface finishes that are going to give the RA, you know, all of those parameters. So it's everything is a recipe that we have to figure out. When a new block comes out, we hone that block and keep testing speed, you know, different abrasives and pressures, speeds and feeds, all of that to achieve the crosshatch that we're looking for. Once we have that down, we just try to be consistent with it. So it's all about consistency from block 1 to 100 and beyond. So that's that. So once we've line honed it, we've decked it, bored it, we've honed it. The next process in the engine block is going to be the cleaning of the block. So we'll do all of our finished deburr work, deburring the top of the cylinders, the bottom of the cylinder, deck surface, the entire block. You know, before we start the machine work, we're going to do a preliminary deburring of the block, so it's safe. You know, you're not going to cut your hands on it and everything.
Mm-hmm.
But the final process is going to be the final deburring of the block. We do that back here. This guy right here is going to be finished deburred. It's pretty far along the way. This is actually one of the new, that's the new LT iron block, 6.6.
Oh, sweet.
So kind of cool. We keep pumping this. I mean, we're really excited about this deal. Kind of like for right now, it's the LSX block of the LT world. So once we finish deburred it and it's fully inspected, we're going to go into this jet wash here. It has high temp water and caustic solution that can clean the block. This is only used for the final cleaning of the block. So we do all of our dirty, you know, initial cleaning in the back. So the water in this thing is really clean. Then once it comes out of there, we'll swing it over into this tank here. We have a hot water heater that allows us to not flash rust the part. So if you put cold water on a freshly machined, comes out hot, you put cold water on it, it'll flash rust and look like shit, you know?
I didn't know that was a thing.
Yeah, for sure. So we have hot water that we can spray it down, do all the final like brushes through it, just like the absolute last final stage of the initial cleaning is done in here. From there, it'll go onto an engine stand. Then it will get in the assembly room. We will then take lacquer thinner the cylinder walls and do like a kind of, you know, real fine cleaning of the cylinder walls. We put ATF the cylinder walls as well. Has a high detergent in it, and that just allows us to really get that any final debris that's in that crosshatch out of it. So again, the cleanliness of the build is paramount to the end results. I mean, I can't stress that enough. It's like you see people building engines in a dusty, dirty environment, and you're just shooting yourself in the foot, you know?
It's like every step of the process is the most important step of the process.
Pretty much. You know, I can explain the cylinder head process real quick.
Yeah, we'll go get over there and figure out how those work. And then after here, we go to the assembly room.
Yep. So essentially, we'll tear down the cylinder heads. If they're getting, they'll get ported in the CNC machines. Then we come over to here. We'll do the guide honing, so installation of guides and the finish honing of the guide. We use a dialed bore gauge, just like we do for the cylinder bores, to get the guides precisely sized for the specific valves that are going in it. We got a couple seat and guide machines. This is doing a set of BR3s here, cutting the valve job on the heads. This will actually machine the angles for the valve job. This is straight out of the CNC machine, and this one is cut. So you can see these are not very well defined. That has a radius cutter on the exhaust that we always use. So we have a very specific angles that we like for that specific cylinder head. So that'll all be done on the flow bench, and we'll design the valve job that gives us the best flow characteristics for that particular port shape and chamber configuration. There's a lot of variables that go into what valve job should be used for a specific cylinder head. So once that's done, we will then go into this room here. So we'll do the finish hand blending of the valve job. So this is a step that sometimes is skipped by others, but we really feel like this is the only way to get the valve job blended into the port work properly. And it gives it that just like hand finished, primo.
I did notice that over there. It kind of, you didn't see as much of the tooling paths in the inside of the valve. It looked just like smooth.
Exactly. For example, like this here, this is all hand blended in.
Yeah.
So you can't see any on the exhaust. You want a nice radius. On the intake, you want to leave a little bit of a sharp angle on the bottom cut. That helps reduce reversion of the airflow coming back in, up from the cylinder back into the intake port. But you want the exhaust super smooth. We blend it all the way up into the 45 or 55 degree seat.
Oh, that's cool. I didn't notice that. I did notice the surface finish difference. I didn't know why though. That's interesting.
So once the cylinder heads are all hand blended, we'll go we'll clean them, clean them, and then we'll go into this room here and do the finished assembly of the cylinder heads. We'll check all the spring pressures, all the install heights, and dial in the installed heights and distance from coil bind for the given camshaft. So we'll measure your actual cam, we'll measure the lobe lift, rocker ratio, and set up your springs accordingly. That's another factor that's important to achieve maximum RPM and valve train stability.
Isn't that something like you want them to be a certain distance from coil bind to like compress and do their thing properly?
Yeah, typically 60 thousandths. 60 thou is good from distance from coil bind. That's like a good, safe, generic, rule of thumb. You can definitely go closer than that in different applications because you do have some level of deflection in the valve train. So on an engine that has a bunch of lift, say like 900 and above, up to over 1 inch of lift, we're going to definitely take into account the deflection of the valve train when setting up the spring pressures and distance from coil bind and all of that.
For those of you who don't know, coil bind is when you squish a spring down the whole way and the coils touch each other. I know some of you guys got a short attention span, so I'm going to put a quick little blip in here now. The shirt I am wearing in this video is at stablesandautoworks.com. Here's what the back of it looks like. It is styled like the old Good Wrench logo from like the mid 90s with the Good Wrench Service Plus. Suck it. Yeah, that's what that's from. Stablesandautoworks.com. The link is in the description if you want to. There'll be more info about that at the end of the video. Get back to the factory tour and learning some stuff about motors.
Exactly.
They're not supposed to touch each other.
It's bad to have your springs in coil bind because essentially you're going to tear something up. Either a lifter, rocker arm, ball, a push rod, something bad is going to happen.
This place is freaking cool. It's like really specialized for high performance engines. Just LS and LT stuff too.
All right, so this is the assembly room. Once we've got everything cleaned, deburred, ready to go, we'll wheel it all in here. This is an example of a short block that's ready to go. This is a 416 LT.
Out of the 6.6 block.
Yeah, this one's set up for like 1,800 horsepower. It's going to be a pretty nasty setup. We've got a set of our Edelbrock heads that we're running on it. This block here has the same cylinder wall thickness as the LSX block, or like very similar to your Dart block. So it's a really stout platform for the LT. It was pretty awesome. So we can go up to 185 in a naturally aspirated application, but this one's a 4070 bore. So we got that. We'll build the complete long block in here, do all aspects of the documentation of, bearing clearances, ring end gaps, piston to valve clearance, degree the cam, set up the pickup tube to pan clearance. I mean, just the list goes on and on of all the things that we're going to document. End play, side clearance. Before this, we've checked the reluctor wheel. It's a big thing on the LS engines is to verify that the reluctor is in the correct location and has the proper run out.
That is the wheel that the crank sensor gets its signal from. Does this one have one that we can see?
It does.
Just so people who don't know, this thingy here.
Yep. So this is the 58X reluctor. We also tack weld it to the crankshaft. You can see right here. So we'll tack weld it. There's definitely instances of reluctor wheels rotating on the crankshaft, which then your car won't start, or it has severely advanced or retarded timing that you didn't call for. It's most likely that your reluctor wheel has moved on the crank. So we tack weld them on all of them just to give that level of reliability.
So if someone has their motor either built fresh or redone here, do they get a sheet? Like what documentation comes back with your motor?
Yeah, exactly. So we document, all engines are documented. We have a detailed build sheet that's going to give you all of those tolerances. Again, bearing clearances, ring end gaps, piston to wall, piston to valve, how much preload, the lash settings, if it's lash or preload, it's basically everything, end play. And then we document that. You'll get that sheet, part numbers of all the components that are in it.
You have like a recommended oil for the bearing clearance value or anything like that?
Yeah, definitely different applications are going to require different oils, different fuels, different oils. So we have a host of recommendations based on the application.
What kind of oil do you like to run and stuff?
I prefer to run late model engines. Oil. We have our our own branded line of synthetic oils, which is pretty badass.
Oh, really?
I'll show you a little bit more about that later.
Huh. Didn't know that.
Yeah. So it's something that has been around for a while. We working with the company to brand that, and it's a very successful, proven product. Just wheeled one out of here. That's getting dynoed later today, and so that was an LT4 long block that we just wheeled out to get dynoed. Another LT that's getting ready to go together, and then this is going to be that 6.6 liter that we just saw that was getting deburred, in the deburr process. So we'll have an engine in here to get short block later this afternoon. This one as well, and then Jim just rolled out a LT4 long block that we're going to dyno here after lunch.
Sweet.
Yep. This is in here. This is where we assemble our intake manifolds. So our billet products, different parts and pieces. This is an example.
This is the stuff everybody drools over and sticks their fingers into.
Yeah. So this is the part that was in the one C machine that was doing the logo. So that's machine there, and that's what bolts here. So we have the single and dual throttle body configurations. The manifold starts out as 234 pounds of aluminum, ends up as 22 when it's done. Takes about 22 hours of machine time, spindle time in the actual machine, and then a good few hours to get it finished, deburred, and assembled. So quite a bit of work and time in one of these pieces here. All dovetail O-ring, so there's no, the O-ring just gets pressed in. Obviously no welding. It's got 56 stainless bolts that hold it all together. It's a unit.
That's that's a lot. I was thinking about all those O-ring grooves, and when you say dovetail, does that mean that it's more open on the inside so the ring doesn't pop out?
Yep, exactly.
Okay.
So you press it in there and it has something kind of to grab onto.
Yeah.
So the tool kind of goes in and then it's cutting a dovetail underneath the surface.
That's cool. There's nothing more annoying than O-rings don't sit where they're supposed to.
Exactly. Here's the dual throttle body snout that you can put on here instead, so you can run twin 90s or twin 102s. Looks really nice for if you're doing like a twin setup, something like that. But here's your dovetail O-ring. It's really hard to see, but it actually has a... Yes, sir.
I've seen CNC machines do a million things a million times, and every time I watch one, I'm just like, wow, that's so cool. Like it just never gets old.
No doubt. Yeah, and then you know, we've got our billet front covers for the LT engines. Photo shop right there. Offices. We do all of our CNC programming in these two offices currently. Do the block, cylinder head, all the solid models, all that. A couple parts areas. Guys eating lunch. Assembly. Got this new laser. It's pretty badass. We're going to be doing, give us the ability to put logos on stuff more efficiently. So we can logo pretty much anything.
Huh.
Lasers. They're awesome.
That's cool. I was wondering what that thing did.
Yep. So we can put logos on retainers to intake manifolds, pretty much anything.
So once an engine is all put together, comes out of the assembly room, just wheel it in here and make sure it works?
Exactly. So this is an LT4 416 that we just finished up for a client. This one is a wet sump configuration. I think it's going in a Cadillac CTSV. So basically, the engine gets bolted up to this cart. This cart then gets registered into the main dyno housing there by these pins, and then the flywheel bolts to this drive plate, which then goes to a drive shaft, which is then hooked to the absorber here. So this is a strain gauge right here. So this is bolted, this is fixed here, and then in here there's a split. So when the engine, it measures the engine torque. Huh. So as this is basically a torque converter inside here. So there's we've got a 15 horse pump and 1,000 gallons of water in the back that goes through the torque converter, through the absorber, and that's what loads the engine. Just as if like a car creates a load. You know, you don't want to just like put your engine in neutral and rev it to the moon, because there's no load on it. It'll just keep going and brake, right? So when you put the load on the engine, then you can kind of get a little bit more into what that engine is capable of producing. So this strain gauge is getting pulled apart, and it's measuring the torque, and based through that it can calculate the horsepower based on torque.
Okay.
And the acceleration, basically of the engine. So the software, the Windyne software, is what's doing that. We've got a coolant tower here. Most engine dynos, majority of the engine dynos are a low pressure flow through coolant system. We opted for this setup here, which is basically like a radiator. It's got a copper piping in there. We run has a thermostat in it, and it allows us to actually build radiator pressure to try to find leaks, essentially. So we're using this engine as a validation tool just as much as to find out how much horsepower it's making, right? So before we deliver your engine, we want to make sure it's 100%, no issues whatsoever. There's always kind of issues of, like, let's say there's a porosity in a casting or something that create a leak that was not found up until this point. There's always a chance of that because now we're introducing heat. So something that could potentially not leak when it's cool can leak when it's hot, right?
Yeah.
So this is just a real world test of the engine, and be able to create that radiator pressure is just another tool that can be used. We also have a leak down, or a blow-by meter, so that's this guy right here. JTEC blow-by meter. This is hooked to the crankcase of the engine, so we can actually verify that the rings are seated. So there's no question of like, oh yeah, it seems like it's good. You know, we literally can monitor that, and we know that the rings, based on how much blow-by the engine has, that it's a healthy engine. So every engine has a certain amount of blow-by. It's how much that's acceptable is the question, right?
Interesting.
So if you see something that's chewing out the breather and it's hurt, it's an engine that's hurt, it has excessive blow-by. But a brand new, fully sealed up engine is going to have low leak down and just very minimal blow-by. We're measuring that in CFM.
That's cool.
So the next, you know, we have all the systems, obviously. We've got a fuel system. That's this box right here. This actually has a Holley fuel pump in there, electric fuel pump. We control that from the dyno console. We'll turn that on. It'll create fuel pressure. We'll light the engine off and then turn that off. And then we have a mechanical fuel pump that runs off of a spud in the back here, so we can have plenty, you know, if we're doing something that's boosted or whatever, we don't have to run some gigantic multiple electric fuel pumps.
Makes sense.
So it's much more reliable over time. We had big fuel pumps on it in the past, and it's like, you know, we're using them all the time, and they just never seem to last. So we went to the mechanical, and we've had this whole setup for a long time. It works great.
That's a really good explanation. I always wondered how, you know, especially it's different if it's carbureted. Like when I went to the Blueprint factory, most of their stuff's carbureted or it's got a sniper on it. There's none of this to worry about, but you're actually hooking all this up to a Holley EFI system every time you do one of these.
Yeah, exactly. So this is our Holley Dominator right here. And we've got the whole harness. We've pretty much run it all. I mean, it's like, you know, obviously 24, 58X reluctor. You've got a, you know, crank trigger, batch fire, sequential, whatever. I mean, so it has a lot of versatility. We can run it. Typically, everything we do is going to be drive-by-wire. So we have a GM pedal that's mounted up underneath here, and I'll show you the dyno console. But we can actually actuate the drive-by-wire from the dyno console, and then we can also set up mechanical throttle bodies as well. But it's a lot easier to run the drive-by-wires, right, Nick?
Oh yeah, way easier.
We run the 1002 sensor, so you see the headers down on the floor there.
Yeah.
It has an O2 per primary and one each collector. We'll be able to run. We monitor the O2s right in this area here on the screen. So when we're doing manifold testing or even just breaking in an engine, we know that not one cylinder is too rich or too lean. One of the biggest things that we see is too much fuel in the break-in process. When we've got customers that are, you know, you always hear that it had a safe tune when it was being broken in.
Yeah.
Sometimes they're so safe, there's so much fuel that you can run into conditions where you're washing the cylinder walls down and having those types of issues. So you don't want to be too rich on your break-in process, because you need that oil. The oil is critical to assist in the breaking in of the rings.
Interesting.
If you have zero oil on the cylinder walls, you're doing damage to the rings. The ring seals on a film of oil.
Makes sense.
That oil is critical. So yeah, through here. So this is how you're going to operate the throttle. Right here, we run the Holley EFI on one computer. Up here, we've got all of our tuning, and then this is kind of the control panel for the dyno itself. You've got your fans. So we've got fans. We've got one huge fan that pulls air out of the dyno cell here. So there's louvers that will open up. It'll draw fresh air in and expel it out the back, as well as all the exhaust. So it's important to have adequate airflow through your dyno cell, so the engine is continuously breathing in fresh air and not contaminated air from its own exhaust.
What's the billet timing cover? Is that for clearance or because it looks cool?
It is to delete the VVT.
Okay.
So it is a VVT, variable valve timing delete front cover. The whole point of the front cover is because we're getting rid of the factory phaser unit on the LT. I don't know if you've ever seen one.
Yeah.
They're pretty bulky and cumbersome. They have a spring inside of it, and when you're reaching higher RPM, higher boost levels, there can be fluctuation where it doesn't stay stable. So we get rid of that factory phaser, run a solid cam gear, and then the front cover solves the issue of positioning the cam sensor in the correct location with the new gear. So that's the main driver for the front cover, is to position the cam sensor in the proper place.
Huh.
And it looks cool.
It looks cool. Yeah, I've never had an LT before, so I don't know why people do that, but I do know about the phaser and the VVT stuff. That's what used to have that.
Yeah, exactly. So we get rid of that and go with the solid cam gear. All of our time and focus and R&D and energy is put into manufacturing horsepower and making it as reliable as possible. So we're not concerned with installing clutches or exhausts and transmissions and all that. All of our guys here are machinists, engine builders, cylinder head porters, fabricators. We've got an incredible crew. That's kind of something that I feel really sets us apart, is the level of guys and the quality people that we have working here. You can have the best equipment in the world, but if you don't have the guys to run it and the right people assembling the engines, you know, you're not going to have that final product. So it's not it's not manufacturing where you can just have an assembly line of just some guy slapping in a bolt and going down. These engines are really, you know, meticulously assembled, and you gotta know what you're doing.
Each one of them has a different application and a different set of circumstances. It's not like, you know, everything's different in this world. No doubt.
And it came down to, like, over these last, you know, 18, 19 years, it's the development of our process, which is crucial. Getting consistency from the first engine of the year to the last engine of the year is really what our process strives to do. And, you know, over all these years, it's you know, you have an issue here and an issue there, and incorporating that into the process. So, like, our checklist is a mile long of what to get an engine out the door. It's been through the ringer, you know, as far as with the process.
So you're the guy. You kind of got to do a little bit of everything, answer everybody, put out all kinds of fires. But if you could just shut all that off for a day and sit in here and do one thing, what's the thing that you like to do the most?
I really like putting together short blocks myself, or putting the assembly of the engine, no doubt. That's probably, I started porting cylinder heads. There's definitely guys better than me at porting cylinder heads, but I can hold my own. We've got the best here. But assembling engines, you know, I really love that.
That's cool. It's like, I even noticed for me, the more things grow and you have to do more stuff in order to do more things, the less of what it is that you first wanted to do occurs. That's why getting the right people to delegate that to is so important. It's the biggest thing, and letting go of those operations that you used to do to the right people. So, like I said, I mean, we've got the best here, and you know, we knock it out of the park every time. What's your next focus of growth? You know, like, we're really expanding our line of manufactured products. So, you know, our intake manifolds, valve covers, front covers, just innovative products that solve problems. You know, the new car comes out, boom, there's a new problem. So we're really trying to stay on the forefront of that. You know, we work with so many shops around the country that, you know, and seeing it and talking to our customers every day, that we're really hands-on as far as listening to the customer and understanding, okay, we need this new product to, everybody's having this issue. So that's really what we're trying to do. The manufacturing, we can really scale that. You know, scaling the custom built engine is something that we've done, but I think it's, I like where we're at as far as we're able to really focus on all the engines that we're building now, and to go and double our amount of engines. You know, I'm not sure that that's the right answer. I think our passion is moving forward with the manufacturing of components, and then continuing to use our engine building to be able to stay, you know, like hands-on on and to be able to listen to the customer to understand what they need. So one thing that we have here, the ability, when we make a product that a lot of our competition does not, is the ability to manufacture and test the product really all in the same location. So you've got cylinder head guys that don't build engines. You've got engine, you know, product manufacturers, engine component manufacturers that don't build engines. Huh. You know what I mean? So now we're the engine builder. We're the delivering to the end user. We're listening to the end user. So, you know, if we need a manifold that works a certain way, we can test it right here. We're not having to go and outsource dyno time. We're not having to, you know, ask somebody to mock up our product on an engine block. It's right here, so we can really try to, our goal is to make products that actually fit and that are usable out of the box. And, you know, in the aftermarket, Yeah.
Sometimes that doesn't happen.
Yeah, it's almost expected to an extent. You're like, wow, this didn't fight me. It's like,
Yeah, that's the funny part, right? It's like, you know, we get some stuff in here, man, and it's just like, how did it even, it's in left field, you know what I mean?
Yeah.
And then it's like, if we made a product like that, we would be called out for that, you know what I mean?
yeah,
Like,
everybody
what the
gets
fuck?
fried on Facebook these days.
Right? So, yeah, man, I don't know, some of this stuff, but yeah, so we're trying to just make products that work, you know, and that work well, look good, and are durable, man. So that's our quest. So if you guys got any products that you think are useful on an LS or an LT engine, we're all open for that, trying to come up and solve problems.
I want to see a cool looking billet high ram lid. Just
There
the
you go.
lid. For cheap guys like me that can't afford the whole manifold,
Right?
just the lid. So it's not the cast lid,
Yep.
and maybe has a little bit more plenum volume to help with the back of the cylinders. I've only seen, I think, one place that makes one, and
Okay.
it's like hard to find.
Okay.
I've always thought, you know,
Hey.
why not just bolt the lid on?
That's solid. I like that.
And it looks cool. Especially if you powder coat the bottom black, and then, you know, all you see is the billet anyway. It's like you're balling on a budget.
I can appreciate that. So we bolt the engine to a steel frame. Steel frame gets bolted to the pallet. So this customer here is receiving a short block and an assembled set of heads.
Oh, so
Pallet back.
every engine gets its own thingy?
Yep, little red cradle. And then again, you know, if it's a local pickup, we'll just pick it up. But if we're shipping it out, then it'll get this box put on it, strapped down, and it's good to go.
That's cool.
Worldwide.
So if anybody has any questions about any of this stuff or wants a motor, some cylinder heads, or cool looking timing covers, where do they find you at?
Go to latemodelengines.com. You can call us at 713-849-4505. Again, we're in Houston, Texas. Hit us up on Instagram, Late Model Engines, same on Facebook, and we'll be happy to help you out, man. We're here to help and love talking horsepower.
Hell yeah.
Cool.
Learned a lot and can't wait to come back and see my 427 on the dyno.
yeah.
Hopefully with as many parts that came out of it as possible.
Nice, we'll do our best.
Well guys, I hope you learned something. There's a lot of learning to be done in that video. Brian is a freaking wealth of knowledge, and he's very good at explaining things too. At least I think so. If you made it this far, just check and see if you're subscribed, because you might not be, or sometimes YouTube might unsubscribe you for some reason. People have had that happen. So just check real quick. And I'd like to know what your favorite part of the video was, what you thought the most interesting thing was, or what you learned, what you liked, what you didn't like, what you think Brian should make, anything like that. I read almost all the comments, believe it or not. I answer as many as I can. We got these new Good Wrench style shirts here. I guess we got Candyman's. Most of them are all up over here though. Yeah, that's what we got. That's like my new favorite shirt style right now. I'm gonna wear this all the time. Also, thinking about finally getting hats on the website. I gotta find boxes, but I think we're gonna do that. And fun fact, the transmission destroyer shirt design, this is all that's left. There's one small, I don't know, like 5 2X's and 1 3X. They are still on the website. When they're gone, they're gone. They're never getting printed again. That's it. Same with the Escalade ones. All we got left are small and 2X. The OG Escalade shirt design will never be printed again. That is it. A new one will come out once the Escalade comes back. But for now, the OG design from 2019, when I was doing all the street car takeover stuff, will be gone forever after those are gone. Also, now Logan is in charge of merch packing and stuff. Still get a note, a handwritten note, but it's from her. I also sign it, so she's the one putting it in bags and stuff. The website does have a tip function, and that goes straight to her. I don't keep any of it. A lot of that has to do with old Cyclops Ruger here. Hey Ruger. He had his eye removed yesterday. He's not very happy. Oh, yep. He's on lots of drugs. He's got his little pillow fort under the desk here. Yeah. He, maybe once he gets a little bit better, we'll get him a little pirate costume with an eye patch and stuff.
That poor baby.
She's trying her hardest to keep it together right now, and I make jokes when situations are not ideal as a coping mechanism. So Anyway, get a shirt. Yeah.
He's called him a cyclops.
I'm sorry, even though you hate me. He's like the troll under the bridge.
I feel so bad for him. He's safe there. He can't like hit anything or hurt his eye.
Yeah.
Or, like his other eye.
Heck, if I was a dog, I'd hang out under there. It's pretty cool. Head over to staplesandautoworks.com. Link is in the description and pinned in the comments. Check it out.